it is not acceptable to run NMB cable into the back of a surface-mount outdoor receptacle box. While the clamp may be inside the house wall, it is not weatherproof. The NMB cable is also not rated for outdoor use within the wall. According to the National Electrical Code, or NEC, NMB cable can only be run outdoors if it is in a conduit or other approved raceway. This is because NMB cable is not ultraviolet resistant and can deteriorate when exposed to sunlight. Additionally, the NEC requires that all electrical connections be made in a weatherproof enclosure. It's important to adhere to these codes to ensure safety and prevent potential hazards. Consider the environment when selecting and installing electrical components. The environment can significantly impact the longevity and safety of electrical installations. Here are key aspects to consider. Firstly, temperature variations. Electrical components have specific temperature ratings. Extreme heat can cause insulation to break down, leading to shorts and fire hazards. Extreme colds can make materials brittle and prone to cracking. Secondly, moisture and humidity. Moisture can cause corrosion and short circuits. Humidity can accelerate the degradation of insulation materials. Weatherproof enclosures and moisture-resistant cables are essential in damp environments. Thirdly, ultraviolet exposure. Sunlight can degrade many types of cable insulation, particularly NMB cable. Using ultraviolet-resistant cables or protecting cables with conduit is crucial in areas with high sun exposure. Fourthly, chemical exposure. Industrial environments may expose electrical components to corrosive chemicals. Using chemical-resistant materials and enclosures is vital to prevent damage and failure. Fifthly, physical stress. Vibration, impact, and abrasion can damage cables and connections. Secure mounting and physical protection are necessary in areas with high physical stress. Sixthly, altitude. At high altitudes, the thinner air can reduce the cooling efficiency of electrical equipment, leading to overheating. Dirtying equipment or providing additional cooling may be necessary. Seventhly, dust and debris. Dusty environments can cause overheating by blocking ventilation. Dust-tight enclosures and regular cleaning can help prevent problems. Eighthly, explosive atmospheres. In areas with flammable gases or dust, explosion-proof equipment is required to prevent ignition. Following these considerations ensures electrical installations are safe, reliable, and compliant with regulations. Remember that proper planning and selection of materials are key to successful electrical projects. When dealing with outdoor installations, special attention to weatherproofing is essential. Weatherproof boxes are designed to protect electrical connections from rain, snow, and other environmental factors. These boxes come in various materials, including metal and plastic, and feature gaskets and seals to prevent moisture ingress. In addition to weatherproof boxes, weatherproof fittings and connectors are also necessary. These fittings ensure a tight seal between the cable and the box, preventing water from entering the electrical system. When selecting weatherproof components, it is important to choose products that are specifically designed for outdoor use and are listed by a recognized testing laboratory. The National Electrical Code provides detailed requirements for outdoor electrical installations. These requirements cover everything from the type of wiring that can be used to the placement of receptacles and lighting fixtures. It is important to consult the NEC and local codes to ensure that all electrical work is performed safely and in compliance with regulations. In this specific situation of installing an outdoor receptacle, there are several important considerations. Firstly, the receptacle must be protected by a ground fault circuit interrupter, or GFCI. A GFCI is a safety device that detects ground faults and quickly shuts off power to the receptacle, reducing the risk of electric shock. Secondly, the receptacle must be installed in a weatherproof box with a weatherproof cover. The cover should be designed to protect the receptacle from rain, snow, and other environmental factors. Thirdly, the wiring must be suitable for outdoor use. NMB cable is not permitted for direct burial or exposure to sunlight. Instead, use ultraviolet-resistant cable or run NMB cable inside a conduit. Consider using Type UF cable, which is designed for direct burial and outdoor use. Fourthly, ensure all connections are tight and properly insulated. Loose connections can cause overheating and arcing, which can lead to fires. Use weatherproof connectors and fittings to prevent moisture from entering the electrical system. Fifthly, inspect the installation regularly. Check for signs of damage, such as cracks, corrosion, or loose connections. Repair any damage immediately to prevent potential hazards. By following these guidelines and adhering to the NEC and local codes, outdoor electrical installations can be performed safely and reliably. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. When working with electricity, safety is paramount. Always to energize the circuit before starting any work. Use appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician. Here are some additional safety tips. Firstly, always turn off the power at the circuit breaker before working on any electrical circuit. Secondly, use a voltage tester to verify that the circuit is de-energized before touching any wires. Thirdly, never work on electrical circuits in wet conditions. Fourthly, use insulated tools to prevent electric shock. Fifthly, wear safety glasses to protect your eyes from sparks and debris. Sixthly, follow the instructions provided by the manufacturer of electrical equipment. Seventhly, never overload electrical circuits. Eighthly, inspect electrical cords and equipment regularly for damage. Ninthly, replace damaged cords and equipment immediately. Tenthly, if you are unsure about any aspect of electrical work, consult a qualified electrician. Adhering to these safety precautions helps to prevent electrical accidents and injuries. Remember that electricity can be dangerous, and it is important to take the necessary precautions to protect yourself and others. In summary, when installing an outdoor receptacle, use a weatherproof box, a weatherproof cover, and suitable wiring. Protect the receptacle with a GFCI and inspect the installation regularly. Prioritize safety and consult with a qualified electrician if you have any questions or concerns. The NEC, or National Electrical Code, is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect the latest technological advancements and safety practices. Adhering to the NEC is essential for ensuring the safety and reliability of electrical systems. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It provides detailed requirements for different types of electrical installations, such as residential, commercial, and industrial. The NEC is not a law, but it is widely adopted by states and local jurisdictions as the basis for their electrical codes. This means that electrical work must comply with the NEC in order to be considered safe and legal. The NEC is organized into chapters, articles, and sections. Each section provides specific requirements for a particular aspect of electrical installation. It is important to consult the NEC when planning and performing electrical work to ensure compliance with regulations. The NEC also includes tables and examples to help clarify the requirements. These tables provide information such as wire ampacities, conduit full capacities, and grounding conductor sizes. The examples illustrate how to apply the NEC requirements in different situations. In addition to the NEC, there are other standards and guidelines that may be relevant to electrical installations. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, the National Fire Protection Association, or NFPA, and Underwriters Laboratories, or OIL. It is important to be aware of these other standards and guidelines and to follow them when applicable. When working with electricity, it is always best to err on the side of caution. If you are unsure about any aspect of electrical work, consult with a qualified electrician or electrical engineer. They can provide guidance and ensure that the work is performed safely and in compliance with regulations. Remember that electrical work can be dangerous, and it is important to take the necessary precautions to protect yourself and others. By following the NEC and other relevant standards and guidelines, electrical installations can be performed safely and reliably. Always prioritize safety and consult with qualified professionals when needed. Understanding wiring methods is crucial for safe and effective electrical installations. Wiring methods refer to the techniques and materials used to install electrical conductors. The National Electrical Code, or NEC, specifies various wiring methods that are permitted for different applications. Some common wiring methods include, firstly, non-metallic sheath cable, or NMB cable. This is a flexible cable consisting of two or more insulated conductors enclosed in a non-metallic sheath. It is commonly used for residential wiring. Secondly, metallic conduit. This is a rigid metal tube used to protect electrical conductors. It is available in various types, such as rigid metal conduit, or RMC, intermediate metal conduit, or IMC, and electrical metallic tubing, or IMT. Thirdly, flexible metal conduit, or FMC. This is a flexible metal tube used to protect electrical conductors. It is often used in applications where flexibility is required. Fourthly, liquid-tight flexible metal conduit, or LFMC. This is a flexible metal tube with a liquid-tight jacket. It is used in wet or damp locations. Fifthly, underground feeder, or UF cable. This is a cable designed for direct burial in the ground. It is commonly used for outdoor lighting and other underground applications. Sixthly, armored cable, or AC. This is a cable consisting of insulated conductors wrapped in a metal armor. It is often used in commercial and industrial applications. The NEC specifies the types of wiring methods that are permitted for different locations and applications. For example, an NMB cable is generally not permitted in damp or wet locations, while a UF cable is specifically designed for underground use. When selecting a wiring method, it is important to consider the environment, the type of conductors being used, and the applicable codes and regulations. It is also important to follow the manufacturer's instructions for installing the wiring method. Proper installation is essential for ensuring the safety and reliability of the electrical system. In addition to selecting the appropriate wiring method, it is also important to use the correct size and type of conductors. The NEC specifies the ampacity of different conductors based on their size and insulation type. The ampacity is the maximum amount of current that a conductor can safely carry. It is important to select conductors with an ampacity that is sufficient for the load they will be serving. Overloading conductors can cause overheating and fires. When installing conductors, it is important to follow the NEC requirements for spacing, support, and protection. Conductors must be properly supported to prevent them from sagging or contacting other objects. They must also be protected from physical damage. In summary, selecting the appropriate wiring method and conductors is crucial for safe and effective electrical installations. Follow the NEC requirements and manufacturer's instructions to ensure that the electrical system is properly installed and protected. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. Understanding overcurrent protection is essential for preventing electrical fires and equipment damage. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. This prevents overheating and potential hazards. A circuit breaker is a device that automatically interrupts the flow of current when an overload or short circuit occurs. It can be reset manually after the fault has been cleared. A fuse is a device that contains a fusible link that melts and breaks the circuit when an overload or short circuit occurs. Fuses must be replaced after they have blown. The National Electrical Code, or NEC, specifies the requirements for overcurrent protection. It requires that all electrical circuits be protected by overcurrent devices sized to protect the conductors and equipment they serve. The NEC also specifies the types of overcurrent devices that are permitted for different applications. When selecting an overcurrent protection device, it is important to consider the ampacity of the conductors being protected, the interrupting rating of the device, and the type of load being served. The ampacity is the maximum amount of current that the conductors can safely carry. The overcurrent device must have an ampacity rating that is equal to or less than the ampacity of the conductors. The interrupting rating is the maximum amount of current that the overcurrent device can safely interrupt. The interrupting rating must be sufficient for the available fault current at the point of installation. The type of load being served can also affect the selection of the overcurrent device. For example, motors and transformers require special types of overcurrent devices that are designed to handle the inrush current. Inrush current is the high current that flows when a motor or transformer is first energized. When installing overcurrent protection devices, it is important to follow the NEC requirements for location, accessibility, and labeling. Overcurrent devices must be located in readily accessible locations and must be clearly labeled to indicate the circuits they protect. It is also important to protect overcurrent devices from physical damage and environmental conditions. Regular inspection and testing of overcurrent protection devices is essential for ensuring their proper operation. Circuit breakers should be tested periodically to verify that they are tripping properly. Fuses should be inspected for signs of damage or deterioration. In summary, overcurrent protection is a critical aspect of electrical safety. Select and install overcurrent protection devices in accordance with the NEC requirements to protect conductors and equipment from overloads and short circuits. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. Grounding is an essential safety measure that protects people from electric shock and equipment from damage. Grounding provides a low resistance path for fault current to flow back to the source, causing the overcurrent protection device to trip and de-energize the circuit. This prevents dangerous voltage from appearing on metal parts of equipment that could be touched by people. The National Electrical Code, or NEC, specifies the requirements for grounding electrical systems. It requires that all electrical systems be grounded to a grounding electrode system. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The grounding electrode system must be connected to the electrical system's neutral conductor and the equipment grounding conductors. The equipment grounding conductors are the wires that connect the metal parts of equipment to the grounding system. These conductors provide a path for fault current to flow back to the source in the event of ground fault. There are two main types of grounding. Firstly, system grounding. This refers to the grounding of the electrical system's neutral conductor. System grounding helps to stabilize the voltage and reduce the risk of voltage surges. Secondly, equipment grounding. This refers to the grounding of the metal parts of equipment. Equipment grounding protects people from electric shock by providing a path for fault current to flow back to the source. When installing grounding systems, it is important to follow the NEC requirements for conductor size, material, and installation methods. Grounding conductors must be sized according to the size of the ungrounded conductors in the circuit. They must also be made of copper or other approved materials. Grounding conductors must be installed in a manner that protects them from physical damage and corrosion. Regular inspection and testing of grounding systems is essential for ensuring their proper operation. Grounding connections should be checked for tightness and corrosion. Grounding electrodes should be tested to verify that they are providing a low resistance path to ground. In summary, grounding is a critical safety measure that protects people from electric shock and equipment from damage. Install and maintain grounding systems in accordance with the NEC requirements to ensure their effectiveness. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. Electrical boxes are enclosures that protect electrical connections and provide a safe mounting location for devices such as receptacles, switches, and lighting fixtures. There are various types of electrical boxes available, each designed for specific applications. Some common types of electrical boxes include, firstly, metal boxes. These are typically made of steel or aluminum and provide excellent protection for electrical connections. They are commonly used in commercial and industrial applications. Secondly, non-metallic boxes. These are typically made of plastic and are lightweight and easy to install. They are commonly used in residential applications. Thirdly, surface mount boxes. These are designed to be mounted on the surface of a wall or ceiling. They are often used when it is not possible to recess the box into the wall or ceiling. Fourthly, recessed boxes. These are designed to be recessed into the wall or ceiling. They provide a clean, finished look. Fifthly, weatherproof boxes. These are designed to protect electrical connections from rain, snow, and other environmental conditions. They are commonly used for outdoor applications. The National Electrical Code, or NEC, specifies the requirements for electrical boxes. It requires that all electrical connections be made inside of an approved electrical box. The NEC also specifies the types of electrical boxes that are permitted for different locations and applications. When selecting an electrical box, it is important to consider the size and type of conductors being used, the number of devices being installed, and the environment in which the box will be located. The box must be large enough to accommodate the conductors and devices without overcrowding. It must also be suitable for the environment in which it will be located. For example, a weatherproof box must be used in outdoor locations. When installing electrical boxes, it is important to follow the NEC requirements for mounting, support, and grounding. The box must be securely mounted to a structural member of the building. It must also be properly supported to prevent it from sagging or falling. The box must be grounded in accordance with the NEC requirements. Regular inspection of electrical boxes is essential for ensuring their safety and proper operation. Check for signs of damage, such as cracks, corrosion, or loose connections. Repair any damage immediately to prevent potential hazards. In summary, electrical boxes are essential components of electrical systems. Select and install electrical boxes in accordance with the NEC requirements to protect electrical connections and provide a safe mounting location for devices. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. Electrical conduit is a raceway used to protect and route electrical wiring. It provides a physical barrier against damage, moisture, and other environmental factors. Conduit is commonly used in commercial, industrial, and residential applications. There are several types of electrical conduit available, each with its own advantages and disadvantages. Some common types of conduit include firstly, rigid metal conduit or RMC. This is a heavy-duty conduit made of steel or aluminum. It provides excellent protection for wiring and is suitable for both indoor and outdoor applications. Secondly, intermediate metal conduit or IMC. This is a lighter weight version of RMC. It provides good protection for wiring and is less expensive than RMC. Thirdly, electrical metallic tubing or IMT. This is a thin-walled conduit made of steel or aluminum. It is easy to bend and cut and is commonly used in indoor applications. Fourthly, flexible metal conduit or FMC. This is a flexible conduit made of steel or aluminum. It is used in applications where flexibility is required. Fifthly, liquid-type flexible metal conduit or LFMC. This is a flexible conduit with a liquid-tight jacket. It is used in wet or damp locations. Sixthly, rigid polyvinyl chloride conduit or PVC. This is a non-metallic conduit made of PVC. It is lightweight, corrosion-resistant, and easy to install. The National Electrical Code, or NEC, specifies the requirements for electrical conduit. It requires that all electrical wiring be protected by conduit or other approved raceway. The NEC also specifies the types of conduit that are permitted for different locations and applications. When selecting electrical conduit, it is important to consider the size and type of wiring being used, the environment in which the conduit will be located, and the applicable codes and regulations. The conduit must be large enough to accommodate the wiring without overcrowding. It must also be suitable for the environment in which it will be located. For example, liquid-type conduit must be used in wet or damp locations. When installing electrical conduit, it is important to follow the NEC requirements for bending, cutting, and joining. Conduit must be bent using approved bending tools to avoid damaging the conduit. It must be cut using a hacksaw or other approved cutting tool. Conduit sections must be joined using approved fittings. Regular inspection of electrical conduit is essential for ensuring its safety and proper operation. Check for signs of damage such as cracks, corrosion, or loose connections. Repair any damage immediately to prevent potential hazards. In summary, electrical conduit is an important component of electrical systems. Select and install electrical conduit in accordance with the NEC requirements to protect wiring and ensure its safety and reliability. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. Understanding electrical codes and standards is crucial for ensuring the safety and compliance of electrical installations. Electrical codes and standards are sets of rules and guidelines that govern the design, installation, and maintenance of electrical systems. These codes and standards are developed by organizations such as the National Fire Protection Association, or NFPA, the Institute of Electrical and Electronics Engineers, or IEE, and Underwriters Laboratories, or UL. The National Electrical Code, or NEC, is the most widely adopted electrical code in the United States. It is published by the NFPA and is updated every 3 years. The NEC provides comprehensive requirements for electrical installations, covering topics such as wiring methods, overcurrent protection, grounding, and equipment installation. In addition to the NEC, there are other electrical codes and standards that may be applicable to specific types of electrical installations. These include standards for industrial control systems, hazardous locations, and renewable energy systems. Electrical codes and standards are enforced by state and local jurisdictions. Electrical inspectors review electrical plans and inspect electrical installations to ensure that they comply with the applicable codes and standards. Compliance with electrical codes and standards is essential for protecting people and property from electrical hazards. Electrical installations that do not comply with codes and standards can be unsafe and can lead to fires, electric shocks, and equipment damage. It is important for electrical contractors, engineers, and other professionals to be familiar with the applicable electrical codes and standards. They should also stay up to date on the latest changes and revisions to these codes and standards. Continuing education and training are essential for maintaining competency in electrical codes and standards. There are many resources available for learning about electrical codes and standards. These include books, courses, seminars, and online resources. It is important to choose reputable sources of information and to consult with qualified professionals if you have any questions or concerns. In summary, understanding electrical codes and standards is crucial for ensuring the safety and compliance of electrical installations. Stay up to date on the latest codes and standards and consult with qualified professionals when needed. Always prioritize safety and follow the applicable codes and standards to protect people and property from electrical hazards. Proper installation techniques are essential for ensuring the safety and reliability of electrical systems. Poorly installed electrical systems can be dangerous and can lead to fires, electric shocks, and equipment damage. There are many different aspects to proper installation techniques, including firstly, planning and preparation. Before starting any electrical work, it is important to plan the installation carefully. This includes determining the location of outlets, switches, and lighting fixtures, as well as selecting the appropriate wiring methods and materials. Secondly, wiring. Proper wiring techniques are essential for ensuring the safety of the electrical system. This includes using the correct size and type of wire, making secure connections, and protecting the wiring from damage. Thirdly, grounding. Grounding is an important safety measure that protects people from electric shock and equipment from damage. It is important to ground the electrical system properly in accordance with the National Electrical Code, or NEC. Fourthly, overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. It is important to select and install overcurrent protection devices properly to prevent electrical fires and equipment damage. Fifthly, device installation. Outlets, switches, and lighting fixtures must be installed properly to ensure their safe and reliable operation. This includes mounting the devices securely, making proper connections, and testing the devices to ensure that they are working correctly. Sixthly, inspection and testing. After the electrical installation is complete, it is important to inspect and test the system to ensure that it is working properly and that it complies with the applicable codes and standards. This includes checking the wiring, grounding, overcurrent protection, and device installation. Proper installation techniques require knowledge, skill, and attention to detail. It is important to follow the NEC and other applicable codes and standards when performing electrical work. It is also important to use the correct tools and equipment and to take the necessary safety precautions. If you are not comfortable performing electrical work, it is best to hire a qualified electrician. Electrical work can be dangerous, and it is important to take the necessary precautions to protect yourself and others. In summary, proper installation techniques are essential for ensuring the safety and reliability of electrical systems. Follow the NEC and other applicable codes and standards, use the correct tools and equipment, and take the necessary safety precautions. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns.